Hello there and welcome back to Advanced SQL. If you've just watched the video on aggregates, that video here would be the perfect companion because it's the video about grouping. And grouping and aggregation typically go hand in hand in SQL. And in a few minutes we will understand why this is the case. There are really two different constructs, but their combination makes for some really interesting and some really very important building blocks for the formulation of SQL queries. Grouping really changes the rules of the game. So we all know the typical relation of a SQL query where from introduces row variable bindings. And then SQL clauses operate row by row. A where predicate will check for a particular row whether a condition is fulfilled. Then the select clause will use the particular row variable bindings and produce one additional row. Processing is row by row. Group by changes all that. Group by makes the query or parts of the query operate group by group. So an entire batch group of rows is processed in its entirety. And this affects all clauses, all SQL clauses that are produced after group by. Before the group by, we are operating row by row as usual. After the group by, we are operating group by group. And you see the order of evaluation in this schematic query here. We of course start with the from, then the where may discard selected row variable bindings. And all of this happens on a row by row basis. But then comes the group by clause, and from then on, in steps 4 and in steps 5 in this having clause, we will come to that, and in the well-known select clause, we are operating group by group now, and that has consequences on the E1 to EM that we are using here, and it also has consequences on the P here, of course. So we are switching from a row by row processing to group by group processing. What defines a group? Which rows make up a group? Which rows are members of the group? That would be the terminology that we're using here. And the answer are the grouping criteria, these G1 to Gn that we are attaching to the group by clause in this query. So these grouping criteria are evaluated for each row. Each row that is passing this where predicate is passed into the group by. And all rows that agree on all grouping criteria, all rows that agree on all n grouping criteria are forming a single group, are forming one group. From then on, these rows agreeing on these n grouping criteria form one entity and then are passed together into this having clause and then are passed together as one group into the select clause. Okay. So let's see what's happened there happens there in detail. So this is a sample query here, and I've chosen particularly simple grouping criteria, just a single grouping criterion, namely the value in column A1 here. So the value in column A1 is the grouping criterion. All rows that agree on their A1 value will form one group. So if this is the peak inside the table that we are currently processing here. You see the A1 row here, the A1 column, I'm sorry about that. And as you can see, all rows agreeing on their A1 value, namely XY in this, XI in this particular case, they are forming the XI group. All rows agreeing on their A1 value, namely XJ, are forming the XJ group. There might be more groups here, I've not displayed them here for space reasons, but all of these rows, all of these two rows and these two rows, groups may of course have different sizes from 1 to the entire table. All of these groups are now processed together. So they are parsed as one into the having clause and they are parsed as one into the select clause from now on. The processing is coarser in a sense. The granularity of processing has been row by row. It's now group by group, and there is some coarsening going on. Groups really partition the rows of the input table, of the table that is contributing the row variable bindings. So each row of the input table, each row belongs to exactly one of these groups. There's no row without any group. There's no row without any group association, and there is no row that would fit in two groups or something. Each row is member of one particular unique group, and so forms a real partition. There are of course no empty groups. A group always has the minimum size of 1. The maximum size of a group is the cardinality of the entire table in the case that all rows of the input table agree on the grouping criterion on, for example, the A1 values here. That would be some pathological case. This fact that we are coarsening the processing, that we are switching from row processing to group processing, has an impact on the select clause, on the admissible, on the valid expression that we may formulate in the select clause. There is a researcher out there actually in functional programming languages, name is Phil Wadler, and he once suggested a view of grouping that I since then happily adopted because it really clarifies things for me and it clarifies the semantics and the behavior of SQL for me. So once you've done a group by, you are switching the type of fields. A field that had a type tau before, after grouping, really now has type bag of tau. An entire bag, a group of values, has been collected together, is forming one entity now of type bag of tau, and is now to processed according to the rules of what can be applied to a bag of taus, not to individual tau values. That really clarifies things on what is possible and what is valid in specifying in the specification of the having and the select clauses of a SQL query. Let's look at this example. After this group by clause, of course, processing is happening in group-wise fashion, and that affects the select clause in this particular query. So this select clause is performed in group-wise fashion. And according to Phil Wadler, the type of TD, the type of this field, has changed from int to bag of int. And I think that's a viewpoint that's rather valid. An entire group of int values is now behind this column reference TD. And specifying TD in this way in the select query actually is illegal and problematic. TD stands for an entire group, a bag of int values, and that's not a valid cell contents in a flat first normal form relational table. We cannot place an entire group of values in such a single table cell. What we could do is we could aggregate this entire bag of values, of int values, to a single value, and that single value that could be placed inside the resulting table cell. So specifying TD here is actually illegal. It would violate the first normal form. Cell values contain single values only. Okay, but what we could do is we could sum over this group. We could sum over the group of values and then yield or extract a single scalar sum value, and that value could be placed inside the result. So this would be the sum of values in this particular group. And this is something that we can place in the result. What about the TB here? The TB has gotten a thumbs up from me, and it's not aggregated, so what's the deal? The deal in this case is, well, we are grouping by TB. We are grouping by TB, so by definition, inside the group, the TB value for all rows is the same. That's the grouping criterion. All rows in a group agree on their TB value. Each group will have a one unique, very well-defined TB value because it's the grouping criterion. So that's what we are using here. And so SQL says, okay, you don't use aggregation here to reduce this to a single value, but that's okay. That's okay in this case because this is the grouping criterion. All rows agree on the TB value anyway, so that's fine. I think semantically, or the proper way to actually express this would be a pseudo aggregate. That's not, let me repeat, that's not part of the SQL language, but it should be or could be part of the SQL language. We could have a pseudo aggregate here that says, hey, take all these identical TB values and reduce them to one single representative TB value in this particular case. This would reduce a bag of TB values to a single TB value that we can place in the table cell. So I'm a big a friend of this, of thinking about aggregation like this, reducing bags of values to single values, and we could do the same with the grouping criterion, and this pseudo aggregate function, the called by Phil Wadler, could do the job here. Okay. As I told you, no, we don't need to write the here. Just specifying TB is already thumbs up for SQL. So let's apply grouping and then aggregation to our playground table, because grouping without aggregation is problematic, as we just discussed. So that would be one sample, grouping and then aggregation over our playground table. This is the playground table. Nothing is being filtered out. Every row is every of these 5 rows is fed into the group by clause. So 5 rows find their way into the group by clause. The group by clause will perform coarsening. After the group by, there will be only 2 groups to be processed: the X group and the Y group. Recall that there are only X and Y textual values in the B column of our playground table. So all clauses processed after the group by, in this case, this is only the select clause, they will operate over 2 groups, not 5 individual rows, but 2 groups. So we expect this entire query to emit 2 rows, and that's exactly what we are seeing here in the sample result. We emit the grouping criterion on itself, and that's valid according to SQL. So we can see in this column, we can see, hey, this is what has been contributed by the X group, and that's what has been contributed by the Y group. The sizes of these groups are 2 and 3 rows, for example. So these count aggregates, the sum aggregate, all of these aggregates are evaluated once per group. Each group gets its own run of its aggregate, and we see the individual aggregates that have been evaluated inside each of the groups. TD, after grouping, is actually a whole bag of values. Sum of TD will reduce that to the sum of these values, and that can be placed inside the table cell, as you can see here. So the D sum in the X group is 60, it's 40 in the Y group. All right. As you can see here, we have a universal quantification in each of the groups, and we check whether the A values in each group, whether all of them are even. Okay, so we are checking for evenness the modulus by 2 here, and the comparison with 0 is actually a predicate that's checking whether TA is even. Are all Boolean universal quantification, are all A values even in that particular group? And you see, hey, by coincidence, the A values in the X group are all even. Some may be odd in the Y group, and we get a false here. And then, for good measure, we are using this string aggregate here just to show and recall that there is more aggregates than just sum, count, and max. The string aggregate will use the string representation of these integer A values, will separate them by a semicolon, form a larger string, and then use that as the aggregate value in this all A column. So we can see all A values in this particular column. So, well, the group had the size of 2, so we're expecting 2 A values that are being contributed here to the string forming, 2 and 4. Okay, we see that 1, 3, 5. Indeed, all of these are even, and none of these are even actually. So the Boolean universal quantification had to yield false in this particular case. All right. So I brought this sample query with me. and we can evaluate it here on the interactive PSQL terminal. That's the result that we are seeing. Very good. Okay, we can use this sample query to also demonstrate the effect of the having clause. The having clause is processed just after the group by. Once the groups have been formed, they are fed into this having clause, and the having clause is associated with the predicate. A predicate that's evaluated once per group. Okay, so the groups are fed one by one into this having clause, and well, we can of course use aggregate functions in these predicates to check properties of entire groups, not of the individual group members. That would be a role for the where clause that we could be placing here. Okay, where operates over rows by rows, having operates over entire groups. So this predicate would check whether the group size is really at least 2. And all groups that cannot meet this size requirement, they would be disregarded and not be forwarded to the evaluation of the select clause. So if we do that, we only see the group of size 3 here, the X group. The Y group could not meet this criterion established by the having predicate. Okay, so having predicates evaluate over entire groups, where predicates evaluate earlier over single individual rows. All right. The grouping criteria that you use in a group by, they actually form a set. The order is irrelevant. We separate these grouping criteria by commata, but actually their order is completely irrelevant. All rows that want to be member of a particular group have to agree on all grouping criteria anyway. There is just no importance on the order of these grouping criteria. You can specify them in any order you want. Okay. If these grouping criteria effectively contain a key for the rows that are fed into the group by, then that's a particular strange case because no two rows agree on their key value. So all the groups that are being formed here using a group by would contain exactly one row. No other row could join the group because no other row would agree on its key value. So if you see a grouping by keys, or if the grouping criteria contain keys, that typically is a query or code smell, I would call it. That sounds or smells fishy to me and should probably be investigated. There are really very, very seldomly cases where this would make sense. Okay. There's an interesting interaction between the expressions that are admissible in the select clause and the notion of functional dependency that you might or might not recall from the lecture DB1. All expressions that are actually functionally dependent on the grouping criteria, all expressions that are dependent on the group functionally dependent on the grouping criteria are actually constant inside a group. So inside a group, the grouping criterion is constant. So any expression that is functionally dependent on such a constant value will also be a constant inside that group and could actually thus be used without problems in a select clause, even without aggregates. Normally, if SQL does not know much about FDs, if SQL does know about primary key functional dependencies, but no other functional dependencies. So even if you as a programmer, as a query author will know, hey, inside this particular group, this expression will have a constant value, no need for aggregation. SQL might not know about this particular functional dependency and will not allow you to use that particular expression E in the select clause if it's not explicitly mentioned as a grouping criterion in the group by clause. Let's see what this means. back to the terminal. Okay, so this is another example over the playground table again. You see that now the grouping criterion is the fact whether the a value is odd or not odd, whether division by 2 has any remainder, yes or no. The remainder must be 0 or 1. So each row that we are feeding here into here will either belong to one or the other group. We expect the forming of 2 groups here. Okay, so let's evaluate that. Okay, so this is the group of those even and those odd a values, and they have sizes 2 and 3. I'm including this example here because sometimes you see people write query like this. Oh, let me write it like this. Okay, so TA is mentioned in the group by clause. That's nice. So I can use TA here in the select clause, and that's no problem for SQL. But that's not really the case. So if you want to use TA here in the select clause, it has to explicitly occur in the group by clause as a grouping criterion also. And in fact, inside such a group, the remainder of the division by 2 is indeed constant. Either a value is even, an a value is even or odd. But this doesn't mean that the a values inside the group are actually unique. We may have, inside the odd group, we may have different odd a values. Which of these a values should be displayed here? SQL cannot tell, so it rejects the query. What SQL can actually display is the fact that the value is either even or odd. That's actually the grouping criterion. And this is something that we can actually do and evaluate successfully. So let's look at this final example query here. So if we recall from our earlier example, inside the B group X for value X, all the A values have been odd. Inside the B group for value Y, all the A values have been even. Okay, that's interesting. So if we group by B, then we can of course output the grouping criterion, no problem about that. But we could also output this expression, no problem, right? Because inside the XB group, this value will be odd for all members. Inside the YB group, this value will be even, or 1, for all the members of the group. So no problem to actually include this in the select clause. But, so let's try that. But SQL rejects the query. It insists that this particular expression here, has to appear in the group by clause if it's to be included in the select clause without mention of any aggregate. Okay, so let's include it in the group by clause then. That's what we do at this particular point. And we can evaluate the query now, and it works fine. The question is whether we have changed the grouping in this with this addition. We have extended the list of grouping criteria just to be able to mention the TA modulo 2 here in the select clause. But have we changed the forming of groups here? Are more groups formed now? And the answer is no, because we knew that inside the B group this would be a constant expression. So this does not affect the number of groups that are being formed. Any rows that agree on their B value will also agree on this particular expression, so they will end up in the same group just like before. So if this expression is functionally dependent on this grouping criterion, we can include it in the grouping list of grouping criteria without any risk of changing the outcome of the overall query. This might be a very subtle point, but there will be points in the lecture and when you write advanced SQL queries where you have to think about functional dependencies and whether it makes sense, whether it's possible to include a particular expression in the select clause without the use of aggregates. And sometimes functional dependencies are the answer to this problem or this question. Okay, so much for grouping and so much for aggregation that is often accompanying grouping when it comes to the evaluation of SQL queries. Okay, so much for now. Looking outside, it's getting dark already, so it's time for me to call this a day. But be there when we continue the course. Stay tuned when we resume our discussion of the core of SQL. We are coming to an end slowly with the core of SQL and can then move on to the more advanced stuff. And that will be fun, I promise. See you then. Take care. Bye.